Now, let's take a look at the registry, the cluster's trusted source for container images. I'll outline good mirroring practices for an air-gapped environment. Then, I'll discuss how to manage the registry efficiently to ensure secure and reliable image delivery. Think of the registry as the heartbeat of an air-gapped cluster. Every workload starts with an image pull from the registry, services, operators, and applications. With no external connections, the registry becomes our single source of truth. If it slows down, the entire cluster feels it. If it fails, nothing moves. Keeping it in close proximity to the cluster and keeping it well organized is what keeps the whole environment stable. Mirroring content for an air-gapped cluster is never quick. We can't just push images from an external network directly into the registry. Instead, the task requires multiple steps. We build the mirror in a connected environment using trusted sources. Then we download and copy the content to encrypted media. That media is then transported to the secure site, where it is uploaded for validation, before pushing it into the internal registry. Every step adds time and risk. When things go wrong, it causes delays, so we need a process that's efficient and auditable. To achieve this, we focus on 4 key practices. First, the process. OC Mirror is the tool that creates a local mirror for air-gapped environments. An image set configuration file defines the images and metadata that are downloaded. We follow standardized workflows that preserve the commands executed, the configuration assets, and the console output. This isn't just housekeeping. It provides traceability for validation and assists with troubleshooting. In a secure environment, that audit trail is non-negotiable. If you need to move content to an air-gapped network, I recommend utilizing the file system option. This option reduces duplication by linking common layers, which significantly minimizes the disk space required. For example, a 60 GB OpenShift release is only 20 GB when mirrored to the file system. Just be mindful when packaging for transfer. Use a method that preserves symbolic links, like tar. Standard zip will break those links, resulting in a corrupted package. Third, be targeted. Only mirror the operator packages and channels you need. You can refine it even further by using min and max versions. That keeps the registry lean, conserves storage, and reduces mirroring time. We only mirror and package one operator at a time. This ensures the blast radius of a corruption is minimized. And finally, catalog permissions. When pushing content to the registry, OC Mirror generates a catalog index. This process creates a file-based catalog that includes only the images that were mirrored. The catalog is first written to local disk, where file permissions are inherited from the user's profile. In high security environments, files are not created with world read access. These restrictive permissions will prevent the OpenShift catalog pods that run under arbitrary user IDs from reading the catalog. To avoid this, set a permissive UMask of 0022 for the session. OC Mirror also generates the Image Digest Mirror Set, or IDMS. This configuration redirects the cluster to pull operator and release images from your registry. The IDMS mirror entries are prefix-based mappings, so only the parent repository path is specified. This allows redirects for all descendant image digests. I would like to highlight the significance of a digest when using a mirror registry. A digest is a cryptographic hash of the image manifest, immutable and verifiable, whereas tags are mutable labels that can be reassigned to a different image, creating a risk of pulling unverified or tampered content. The immutability of digests guarantee that every deployment uses verified images. Once the IDMS is applied, the image registry operator creates a new machine configuration, and the machine config operator rolls it out to every node. Every time the IDMS changes, the cluster triggers a full machine config rollout, so it's critical to manage changes. Inserts are typically quick, but updates and deletes require node drains and reboots. So plan ahead to avoid unnecessary rollouts across the cluster. Even after the IDMS is configured, we need the ability to modify the registry for upgrades and to manage registry bloat. This is where the idea of a virtual endpoint helps. It gives us a single, stable reference that enables the addition or removal of images from the registry without ever touching the machine config. As you can see on the slide, we are serving multiple versions of OpenShift from a single virtual endpoint. From a technology standpoint, you can implement this in several ways. Some registries provide native virtual repository features. If yours doesn't, the same result can be achieved with a reverse proxy. Either method will enable you to add or remove content efficiently. Our mirror registry now holds over 100,000 artifacts, and that's with active curation. Without deliberate organization, that sheer volume quickly turns into chaos. Troubleshooting becomes painful, upgrades slow down, and even simple tasks take longer. That's why organizing the registry isn't optional, it's mandatory. By structuring repositories, using consistent naming, and archiving what's obsolete, we keep the environment predictable and upgrades manageable. A well-organized registry is what allows us to scale, audit, and troubleshoot with confidence. With all the content loaded, we now need to ensure our registry is trusted. In an air-gapped environment, identities are signed by an internal certificate authority, or CA. By default, applications trust only the public CAs. To enable secure communication, the enterprise CAs must be added to the trust stores of the applications on the registry server and the cluster. Every endpoint, from the registry server through to cluster ingress points, needs signed certificates issued by the enterprise CA. And don't forget to plan certificate renewals. Operations teams need to track expiration dates and renew certificates well in advance. Expired certificates cause service outages.